Hello and welcome to Smells Like ML. You might remember one of our earliest projects, Yoga AI, where we built a virtual yoga instructor, SpecMirror, on a Raspberry Pi.
We want to extend that project into a full-blown smart home assistant that can process interactions through audio and visual cues, but to do so, we need a more powerful board, so we're using the Jetson Xavier NX.
Let's get into it.
As mentioned, we're using the NVIDIA Xavier NX. It's powerful enough to run many models simultaneously, making it a great fit for the task.
Check out the blog where we unbox and benchmark the NX.
The other major components are
A USB camera, this one has a nice wide angle, and a USB microphone. For the display, we used a TV screen behind our one-way mirror we repurposed from the Yoga AI project. We want to prototype the following functionality: chatbot to answer questions, facial recognition to identify users, logging and tracking various activities and attributes of a user.
the assistant will require running multiple models simultaneously with various interdependencies, and so we decided to deploy these features into containers as microservices.
This will give us more flexibility in prototyping the assistant and will make upgrades easier with minimal downtimes.
Containerization also makes the application more resilient and simplifies deployment to other hardware environments as development continues. Fortunately, the NVIDIA team released a demo showcasing the NX running multiple containerized models. We use this as a reference implementation.
Multiple containers will need to access the webcam, so we use GStreamer and v4L2 loopback to duplicate the video stream. For the chatbot, we'll use an Elasticsearch engine to index our question-answer pairs. Now we containerize our various features. The chatbot container will use the ASR engine to transform speech to text, then query our search engine to find the best answer. It will also use signals from our gaze detection container to determine when to answer a question. We also use a simple facial recognition container to determine who is interacting with the assistant. To track and log activities, we have an Action AI activity recognition container. All of these containers will provide information to our Flask web app, which will serve our UI for the mirror. Let's start with the chatbot.
How does Bert answer questions?
As a demo, we wanted our bot to answer medically related questions. We then used the Jasper ASR engine container to translate our spoken question into text. Next, we query the search engine to find the most similar question in our corpus and return that question's corresponding answer. Once we have our answer, we need to present it to the user. Here we use a speech synthesizer to convert it into sound.
How do I stop smoking?
Good for you for wanting to quit smoking. It's the best thing you can do for your health. Have you ever tried quitting before? It may not be as bad as you anticipate. Some people have very little trouble stopping smoking. Others have to try several times before they quit. Studies show that people have a better chance of quitting the first time if they taper off gradually, set a firm quit date, use a stop smoking aid, either over-the-counter patches or gum or a prescription medication.
We want the chatbot to answer a question when we're speaking to it and not to ambient conversation.
We add gaze detection from the multi-container demo to only answer questions when we are directly looking at the camera. The gaze detection container can return a Boolean variable that indicates if the user is making eye contact. The chatbot then receives the Boolean variable from the gaze detection container using MQTT.
We also want the assistant to deliver a personalized experience, so we use facial recognition.
We use a lightweight Python module that only requires a sample image for each user. The information will then be passed to the Flask app to display and can be accessed by other containers for logging and tracking.
Since we exercise frequently in front of the smart mirror, we use Action AI to identify basic movements.
Combining this with our facial recognition module, we can track each individual's progress and present their stats on the screen.
Later, we can use the data collected to analyze our progress over time.
We built a simple Flask app that can process relevant stats and present them to a user via a basic HTML page.
We hope this proof of concept inspires you to build your own. Smell you later.